shipment of 10 microwave ovens contains 3 defective units. In how many ways can a vending company purchase 4 of these units and receive A, all good units, or B, 2 good units, and C, at least 2 good units, at least. Okay, so we have 3 scenarios here. Let's look at the first scenario, A. All right, so it says all good units. Okay, so what do we know? We know there's 10 total microwave ovens. There's 10 total. 3, okay, so if we have a shipment of 10, there's 3 defective units. And I don't know how they figured that out. Maybe they just did like stats and stuff and they figured like, normally when you have 10, a shipment of 10, 3 of them are defective. That's just on average. Okay, how many ways can a vending company purchase for these units? Okay, so there's 3 that are defective, which means there's 7 that are not defective. Okay, so we have a total of 7 that are not defective. What are the chances that we get 4 of these units? Okay, so out of the 7 are how many different outcomes would have 4 not defective? So out of the 7, that means we're choosing 4. And I'm going to do a combination because the order in which you're getting these microwaves doesn't matter. If you're purchasing 4 of these out of the 10, how many different ways can you get 4 that are not defective? It doesn't matter the order, so that's why I'm using C. If the order did matter, I would use P. So this would be 7 factorial over 7 minus 4 factorial times 4 factorial. Okay, so this is going to be 3 factorial. So I'm going to take the 7 down to 4 because he's the bigger number. And then I have 3 factorial and 4 factorial on the bottom. The 4 factorial is divided and they cancel out because they equal 1. And then the 3 factorial is 6, and so I'm going to cross out the 6. So we have 7 times 5, which is 35. There's 35 different ways we can get 4 not defective units. Okay, now we have B. Now, if you're watching this video, take a pause and try to think through these scenarios by yourself before I do them all. Because once I do them, you can't say or claim that you understand it by redoing this problem later. It's better if you can do it on your own before you see somebody do it. Okay, so the next one says 2 of the units are good. Okay, so they're still purchasing 4. Okay, that's still true, but now only 2 of them are good. Okay, so this is what we're gonna have to do here. We're gonna have to take so only 2 units are good. All units are good. 2 good units. Okay, so there's 7 choose 2 ways that we can choose 2 good units. Okay, and then this means that the other 2 units that we're choosing, because we're choosing 4 total, are defective. And so that means we have to now multiply this number by, because this is the not defective, we have to multiply that number by the number of ways we can choose 2 defective units. And there's 3 total defective units out of a shipment of 10. So we multiply these 2 numbers, that'll give us a total number of ways we can get exactly 2 good units. So we have 7 factorial over 7 minus 2 factorial, 5 factorial, times 3 factorial over 3 minus 2 factorial, which is going to be 1 factorial, 2 factorial. Okay, and then let's see. Simplifying stuff. Oh, I messed up. This is not supposed to be 5 right there. That's supposed to be 2 factorial. Okay, this is 5 factorial. Okay, so simplifying the first one, let's write 7 times 6. And then the 5 factorial is gone on the bottom. We just have 2 factorial. So that's going to be 42 on the top. And actually, I could have simplified that. Let's simplify that. 2 factorial cancels away. And then this is going to be 3 times 7, which is 21 times. Now simplifying this guy right here, you would have just 3 up top, because if I cancel the 2 factorial out, because this is 3 times 2 factorial, so I cancel the 2 factorials out. We just have 3 up top, and then this is 1 factorial, which is just 1. So it's 21 times 3, which is going to be 63. There's 63 different ways we can get exactly 2 good units. Now the last one says at least 2 good units. And so that's getting only one good unit, or we're getting 2 good units. Okay, so we're going to add a number to the 63. So how many different ways can we get 1 good unit? Oh wait, no, I'm sorry, not 1. I read that wrong. This is at least 2 good units. So it's 2 good units, or 3 good units, or 4 good units. So that means this is 4 good units. So I'm going to add 35 to that number. And now I need to also find how many different ways we can get 3 good units. So we're going to do the same process as before. So we're going to take to 7, we're going to choose 3 out of that, and we're going to multiply it times 3 times, and choosing 1 out of that. Okay, so 7 factorial over 4 factorial, 3 factorial. I'm starting to do shortcuts here. 7 minus 3 is 4, and so that's a combination there. And then we have 3 factorial over 2 factorial times 1 factorial. That's going to be pretty much the same as this guy up here. So that's going to be a 3. And then this guy over here, he's going to be, let's write stuff out. 7 times 6 times 5. Oh man, running out of space here. 7 times 6 times 5. And then the 4 factorial is going to cancel out with that guy. So on the bottom, we just have a 3 factorial, which we know is 6. Okay, so we have 7 times 5 times, what was this, a 3? So 7 times 5 times 3. So 7 times 5 is 35 times 3. So 35 times 3. Okay, that's going to be 90, 105. So is that right? Yes, that's right. So I'm going to add 105 to this. And then once I add up all those, I get my answer to letter C. So that's 63 plus 35 plus 105. It's 203. So C's answer is 203.